So back a few weeks ago, we talked about several type of number systems. We talked about base 10, our number system, base 2. That's machine language. That's the number systems of computers and digital devices. But then there were these other number systems. There was base 8. There was hexadecimal. But then if you remember, we talked about a special type of code. There were numbers and then there were codes. This code was called BCD. BCD stands for binary coded decimal. With BCD, instead of just like counting 0 through, with BCD you can represent decimal digits up to 9. But instead of counting in binary like this, like a 0, a 1, a 1, 0, a 1, 1, what you do is you use 4 bits to represent the decimal digits 0 through 9. So what I'm saying is, instead of writing a decimal 1 in binary as 0, I'd have to show this as 4 zeros. Or instead of writing a decimal 2 as a 1 0, I'd have to show this using 4 bits. So it would be 0 0 1 0. And so I told you later on in the semester we talk about why that's the case. So I kind of want to show you why we use these 4 bits to represent BCD or in BCD. And then I want to apply that to our last practice design problem. And this will help get you ready for exam, the final exam. So let me put the problem statement back on the screen, and I left it up there on purpose just so you guys can have a chance to look at it. But if you look close at this figure, zoom in on figure 1. Zoom in on it with your magnifier. And what you see in figure 1 is it's a digital device called a 7-segment display. A 7-segment display. And you've seen these. Anytime you display digits digitally, you can either use a 7-segment display based on LED technology, or you can use a 7-segment display based on LCD. LED, that's a light emitting diode. LCD is liquid crystal display. You've seen these. So if I display digits and you can see it with the lights off, it actually lights up, then the digits you're looking at are composed or put together using little lights called LEDs, light emitting diodes. Whereas if you can display digits 0 through 9 digitally and it doesn't light up, it's just kind of like a gray back color, that's called liquid crystal display. So either of those technologies, LEDs or LCDs, each of those will require the use of BCD. BCD is binary coded decimal. And that's where you use 4 bits to represent the decimal numbers 0 through 9 in binary. So I just want you to zoom in on figure 1 so we can kind of see how this 7-segment display is constructed. So zoom way in on that. And this is one that uses LED technology. So what you have here you have basically 8 elongated diodes. 8 elongated diodes that have unique letters of the alphabet associated with them. So there's a diode A, a diode B, a diode C, all the way through G. And so what happens is I can light up any one of those diodes by applying a voltage to it. And notice that the diodes are arranged in the figure 8 pattern. So the way this works is, if you look at figure 2, you put your BCD number over here. So maybe I'll put number 9. So number 9 would be I would have a 1 0 0 1 in binary. I gotta use 4 bits. So if let's say I used maybe I use a 2. A 2 would be a 1 0 in binary, but I'd have to show that as a 0 0 1 2. So the first rule is to use BCD, you have to use 4 bits. So if your binary number calls for less than 4 bits, you just put leading zeros in front of it. You got to have 4 bits. But if I were to put on the BCD input 1 0, 0, 1. That would be a binary 9, and over here it would light up certain LEDs. And in this case, it would light up LED A, LED B, LED G, LED F, LED C, and LED D. And if you want to know, well, how do you know that? Because what this will do is whatever binary input you put on the left side in BCD, it'll give you that decimal digit or display over here. It'll light up those diodes to give you that particular digit, decimal digit. So if I want a 9, I put in 9 over here in binary in BCD, and it'll light up the diodes that give me a 9. So this, I'll just move my, let me mark it. It's going to light up these diodes to give a 9. What? Wait a minute. Marker. It's going to light up these diodes right here. Now some people, when they make a 9, they just put it, but I think a 9 has a little tail right here. I don't know if you guys can see the line that I'm drawing or not. But what I'm showing is you can light up any set of diodes here to give you any of the digits 0 through 9. So let's do one more. Let's say that I wanted the number, I don't know, the number 6. So for 6, I would light up, I would put a binary 6 over here. Remember, you got to use 4 bits. You put a binary 6 on the left, and it'll light up the corresponding LEDs to give me the decimal digit 6 in figure 1. So if I put the binary equivalent of 6 on the inputs, on the BCD input, it'll light up segment A, it'll light up segment F, G, D, C, and G. It'll light up the ones to give me the decimal digit 6, which is this one, this one, this one, that one, and that one. So typically when you deal with digital devices, I guess in the application with a PLC, if you have a digital readout or a device called a thumb wheel, then you work with BCD, binary coded decimal. So this device here is a BCD to 7-segment decoder. Now, what do we want to do with this? Well, take a second. I know some of you just logged on. Take a second and read the problem statement below this. I'll give you a minute to read it, and I want to talk about it. Okay, let's just kind of run through this together. And what we're going to do today is we'll talk about the problem statement, and I'm going to give you a partial solution to this just to kind of point you in the right direction. And then what I want you to do is complete this on your own. And you can submit this to me for a grade. You'll complete this on your own. You guys should actually talk to each other and compare work to make sure you did everything correctly. I'll display the solution on Monday, but you submit it to me before Monday. You can get credit for it for submitting this to me before Monday. So let's talk about what we're going to do, and I'll give you kind of a partial solution to it, and then you can complete it. Do it over the weekend for practice, and if you can do practice, design practice 1 was just meant to show you that you can use a truth table. Remember, that's the one where we had to design a simple logic circuit that will control a light from 2 locations. But we only wanted the light to be on when both switches were off or both switches were on. For any other switch condition, the light lamp would be off. So the point of that one was just to show you can use a truth table to give you the terms for the Boolean expression to give you the correct logic for your PLC. And so we did that. It was a really simple problem. And then we said, all right, let's go to something where we have to control devices, and that was the one where we had the design practice 2. There was a flame incinerator used to kill viruses and bacteria, and you had to control the valve to let the gas or the exhaust in and out, and you want to make sure that the flame was burning. And we had redundant sensors that we had to control. So that was more practice. And this one, Design 3, is more of the same thing. And if you can go through those 3 and understand it, then your final exam should be pretty simple and enjoyable. So I don't think you have any problem with it. So this is your final practice. And again, I'm going to leave you guys to kind of do this on your own. I'll just point you in the right direction. So what are we going to do? It says design a truth table for BCD to 7-segment display decoder that demonstrates the relationship between the 4 inputs of the decoder, A, B, C, and D, and each segment of the 7-segment display. For example, to display the decimal number 0, the required BCD code would be 000 BCD. And each segment, A, B, C, D, E, and F, of the 7-segment display would need to light up. Therefore, you would show a binary 1 in each of the related output columns of the truth table. And so I'll show you a truth table in just a second. But so what he's saying here is you put binary or BCD zeros for each of the inputs A, B, C, and D. And then what it'll do is it'll light up the corresponding LEDs over here on the 7-segment display to give you the decimal 0. It will light up the A, will light up the B, will light up the C, the D, the E, and the F. It would not light up the G. If it lit up G, then you would be looking at the decimal digit 8 instead of 0. So since it would light up A, B, C, D, E, and F in the truth table, you'll put a 1, a 1, a 1, a 1 in each of the columns that correspond to these LEDs. So now we actually go to the solution. I can actually show you better. All right.
I don't know if it's just me, Professor, but I can't see if you're writing anything on a whiteboard at all.
You can't see me writing on the whiteboard?
No.
Can you guys see the document?
Yes.
Okay. Well, let me just, I don't know why. Let me try it again. Let me try something. Can you see this? You still can't see it?
I don't know if it's just me, but I still can't see a whiteboard. But I can see the
Yeah,
problem.
I don't see the
I can't
whiteboard
see the
either.
whiteboard either.
Okay. But you can see the document.
Correct.
Yeah.
Okay. Well, I won't use the whiteboard. I'm sorry. I'm going to get rid of it. But you'll be able to see it. So just kind of follow it. Follow this document, and I'll do it without the whiteboard. Okay. So what you're going to do here, here's the solution. Here's what you do. I'm going to go down and go to here. This is the truth table. So you can actually print this off your Canvas. You'll see, if you haven't been on Canvas yet, you have the problem statement and you have this truth table. And you want to print these off because you'll need them to be side by side as you go through. You got to be kind of detailed and keep things in order. But what I've done here on the left here where it says BCD inputs, what I've done there is I have labeled the inputs A, B, C, and D. This corresponds to the inputs on the decoder. It corresponds to the A, the B, the C. It corresponds to these BCD inputs. So I put all the inputs over there, and basically what you're going to do is you're going to, when you fill your truth table out on your BCD inputs, all you're doing here is what we've done before when we created a truth table. Remember I said you're counting in binary? So you're going to list all the possible possibilities for the digits 0 through 15. And so what I've done here under column D, that's the capital D, you start off with the first row being 0. We got 4 inputs. So remember the number of rows of the truth table is determined by the relationship 2 to the nth power, where n is the number of inputs. That gives you the number of rows in the truth table. we have 4 inputs, A, B, C, and D, so we're going to need 16 rows. And so I have them labeled decimal 0 through 15. There's our 16 rows, and what you do is you just fill out your truth table. You have a choice. You can count 0 through 15 in binary. I don't like to do that. It's much easier to start with D, capital D, and then if you start off with 0, 0, 0, 0 in the first row, you alternate every other bit, 0, 1, 0, 1, all the way down. And then the next one is every 2 bits. So for C, we got 0, 0, 1, 1. B would be every 4 bits, and then every 8 bits, and then I gave you something bigger, every 16, 32, and so forth. The one on the final exam is probably like this one. So the first thing to do is to get your truth table correct, your numbering. Once you've done that, what you want to do is for every BCD number over here listed, like for decimal number 0, the BCD equivalent would be 0, 0, 0, 0. What you want to do is look at which LEDs on the 77 display you would have to light up to give you a 0. Well, to give you a 0, you'd have to light up segment A, segment B, segment C, D, E, and F. That will give you the display of 0. You would not light up G. If I lit up G, that would give you the number 8. We want 0, so it's A, B, C, D, everything except for G. So if I go down to my truth table, you'll see here that for 0, I have a 1 for segment A, I have a 1 for segment B, I have a 1 for all of those LED segments except for G. So each one of these over here is an output. So this truth table is a little different because normally we have one output, but this shows you can actually have more than one output on a single truth table if you have more than one outcome that you want. So what you're going to do is start your problem like this. You're going to list the binary numbers from 0 through 15. You'll count in binary under BCD inputs. But then you got to remember that BCD basically cuts off at 9. We only go up to 9 in BCD because for every digit over 9, we'd have to use 2 symbols. Like for a 10, there's a 1 and a 0. For a 13, there's a 1 and a 3. And what you would do is use a BCD number, a 4-bit number for each of those digits. So if I want to display a 13, I will display the 1 using 4 bits and the 3 using 4 bits. Therefore, BCD cuts off at 9. So in this table, even though you've counted 0 through 15, for this project that we're doing, you're only really using the digits 0 through 9. So that's going to save you some time. So once you fill your table out, and you realize that you're only using the digits 0 through 9, then the table you're actually using is the one I'm showing you. You don't have to do 10, 11, 12, all the way through 15. Just forget about those. And then what you're going to do is fill the table out like this. So what I've done here is I figured out which of the 7 display, which LEDs I got to light up to give me the decimal number over here on the far left. So for 0, as I said before, I got to light up all the segments except for G. And so I put a 1 under each LED except for G. For the number 1, I only have to light up B and C. If I go back to the picture and you look at figure 1, if I light up LED B and LED C, I have the decimal number 1. And so in my table, for decimal number 1, I show, got that one. For decimal number 1, I show LED, B, and C. So what you're going to do is, for each of these decimal numbers, 0 through 9, what LEDs do I need to light up to display that particular number? And then you're going to put a 1 under each segment for each letter for the 7-segment display. So you got to be able to get this table right here. Does everybody understand what I'm saying, how to get that table? That's actually the hardest part of it. If you can do that, and it's not particularly hard, it's just making sure you put the ones in the right place. It's easy to make a mistake. So when I did this, I had this document, this figure right here, figure 1. I had that kind of right beside my truth table, so I can look at it as I fill it out. It's just better if you do it that way, so you won't make a mistake. So basically, when you do that, you'll end up with the table like this, but they're only concerned with this first column, A. They want to know what logic would you use if I only wanted to light up segment A every time I put a number in the BCD input. And so on the final truth table down here, you'll go down and you'll see that I've gotten rid of all these other outputs, B through G, because I'm only looking at A. I'm only looking at A. If you go back to the original problem statement, and if you read it, let's go back to that. Number 2 says, design the truth table that will decode the 4-bit input to light up a single segment A of the 7-segment display. Write each term of the SOP in the last column of the truth table. So that's what I was showing you here, is that we're only concerned with segment A. So I got rid of all the other columns, B through G, and I'm only looking at A. So once you fill this out, whatever your output, whatever your answers are for A, you migrate those down to this table, and then what you want to do is write each term that will give you an output or light up segment A. So how did I get this first term? Well, for decimal 0, I listed out my 4 inputs, A, B, C, and D, and since they're all zeros, I would not those. I jump down here because we don't light up A to give us a 1, but we do light up a segment A to give us a 2. And to do that, for 2, my binary, my BCD was 0, 0, 1, 0. So I have 2 zeros. So that means I'm going to have an A. A is a 0, so I knot it. B is a 0, so I knot it. Wherever I have a 0 in my SOP term, I knot it. If I have a 1, I leave that uncomplimented. So it looks like right here, I have a 0 right there. So that D actually should be knotted. Everybody see what I'm saying? You end up with a bunch of terms over here. And you'll OR those together like we've been doing. And then you'll simply put those in the truth table. Put them in the truth table and show me the logic to decode segment A. So that's number 3. Use a K-map to find the minimized logic to implement the truth table design in step 2 above. And then you want to draw the logic circuit using gates, not your PLC instructions, but you want to just show the logic gates for this. Was everybody clear on what to do? Yes, no, kinda.
Seems to make sense.
Okay. All right, well, as I said, you guys are going to do this. This is kind of a self-directed one. I want you to do it. We'll compare our answers on Monday. And speaking of Monday, first of all, thank you. A lot of people turning in their exam too, and I actually have 1 or 2 people that's completed the 3rd exam. It's just questions and doing a little bit of research, which I think you'll find pretty interesting. So someone, I know at least one person's done exam 3, but I think it might be 2. So I'm getting a lot more people. Got a lot of exam 2s last night. I got 1 early this morning. So I'll get those graded. Make sure for exam 2 that I text you back with your grade. You know, if it's more than I say 2 days and I haven't texted you back, you might want to send me another text or say, hey, I sent you my link. Usually in a day or 2, I'll go through. I'll look at your logic. I'll run your video and I'll give you a grade right there on the spot, and I'll text you back what your grade is. So make sure you hear from me in a day or two. If not, you want to, just send me another text and remind me. But exam 3 is out there. Get that out the way. And I think what we can do, guys, is wrap up next week. We'll wrap up next week, and then I want you guys to decide when you want your final exam. Remember, the final exam is not over the whole semester. It's just over this stuff that we've been talking about since our lab period was over. Just this SOP stuff, minimization techniques, that kind of stuff. So it'll be very similar to what we've been going through on these design projects and the practice problems we've been doing for the last week or so. Anybody have any questions for me?
If you don't have access to a printer at this moment to print off the actual documents for like the practice, would you be fine with us like hand drawing those, and like if we use like a straight edge to make those graphs and everything with those bars?
Yeah, that'll be fine. That'll be fine with me, because this is just for you guys. Now, what you will have to print off is the exam. So if anybody has any issues with that, I don't know if you guys are local. I don't know if are you guys on campus, or where are you? Are you still at is everybody in Cincinnati? I think I see students on the campus, so I don't know.
Some of us.
I mean, some
are
people
from
are.
Cincinnati. Some people are.
If printing is a big issue, and if you're in Cincinnati, if you're home, I'll print off a bunch of them, and I can meet you somewhere and hand them out. Let me know. And you'll have time. I mean, you'll have plenty of time. We're gonna finish the term early, and you'll have plenty of time. We need to figure out what day we want the exam, and you'll have time to do it. It won't be due you'll have time. It won't be due the same day I give it out. So you'll have a little bit of time, a couple days to do it, and then you can submit it. So if I have to hand deliver it, meet you on campus, we'll work it out. So, but as far as the practice and that kind of stuff, I don't care if you hand draw it. I just want the exam on the actual document that I give you. So let me know. We'll talk about it. If I need to meet you, no problem at all. We can do that. Buy me a beer or something, and I'll meet you. Is that all right? Okay. Well,
I put my link in the note section in the exam too. Is that okay?
you put your link where?
In the note.
Oh, no, you want to text it to me, Ty.
Oh, I text you the link?
Yeah, because it'll be because sometimes I might be in the middle of dinner and decide to grade some. I might be, and it's just easier. I can hit that link and go and look at it and get the grade in. I mean, I have literally thousands of papers to grade. Not literally, but probably hundreds. So it's way easier if you send me a link. You can use whatever you want, but YouTube says I don't ever have any problem when you put it on YouTube. I can hit that link. I can be over my girlfriend. I can be anywhere on her phone, and I can grade your work. So yeah, that's way more convenient for me.
Okay.
Well, guys, have a good weekend. We'll meet Monday. I think Monday we have there's one more short lecture on output devices. I need to see, but I think Monday or Wednesday we're going to be wrapping up the semester. So we'll see Monday. I'll let you know, but then we'll talk about when we want to have the final. Then that'll be it. So if nobody has any more questions for me, guys, have a great weekend. I'll talk to you on Monday.
I just wanted to check for the video. Do we have to go like line by line and explain, or just show that it actually operates?
I have students do it either way. What the minimum requirements is that you have the deliverables right there, and you want to go through and show me that each deliverable, as you kind of go through, show me that your program does what each deliverable says. So that's the minimum. Some students
so it could be pretty much like the one that you had on campus.
Yes.
Okay.
But it'll be like that. But you just want to explain. Okay, I'm the door is opening. You want to explain kind of what's going on. Speak to each deliverable as you go through. Now you don't have to. I do have some students that they put their camera on the program and they actually explain what was going through detailed. You don't have to do that. I mean, it's kind of nice if you do, but you don't have to. As long as you show me the deliverables are met and kind of explain what as you go through each deliverable, then you're good to go.
Okay, works for me. Thanks.
Anybody else? All right, I'm gonna go find me some breakfast and get back from my other class. I'll see you guys later. If anything else that comes up, please send me a text.